We are children of gravity. For 3.5 billion years, life on Earth has evolved under a constant, unwavering pull. It is the invisible architect of our biology, sculpting our bones, pressurizing our blood, and telling our senses which way is down. But the cosmos is indifferent to our comfort. In the void, that architect vanishes. We call it microgravity or zero-G. It looks like freedom, but to the human body, it is a slow-motion catastrophe. Without weight, the body panics. Bones dissolve, losing mass at a rate of over 1% per month. The cardiovascular system weakens, no longer fighting to pump blood uphill. Vision blurs as fluid pressure deforms the very shape of our eyeballs. If we are to become a true spacefaring civilization, if we are to leave the cradle, we cannot simply survive in space. We must conquer it. We cannot live in the void. We must take the Earth with us. In 1974, a visionary physicist named Gerard K. O'Neill asked a radical question. Is a planetary surface really the best place for an expanding technological civilization? His answer was this: the O'Neill cylinder. Imagine a structure of titanic proportions, 2 counter-rotating cylinders, each 20 miles long and 5 miles in diameter. These are not cramped space stations. They are continent-sized ecosystems in steel bottles. Inside, there are forests, rivers, and cities. But the most important feature is invisible. It is the ghost in the machine, artificial gravity. We do not possess the technology to manipulate gravity fields like science fiction. Instead, we use inertia. We spin the world. Physics is strict here. To a person standing on the interior hull, the floor is actually rushing up to meet their feet, constantly accelerating them toward the center of the cylinder. This is centripetal force, the hull pushing you inward. But your body, possessing inertia, simply wants to travel in a straight line, tangent to the spin. The floor prevents this. That resistance, the floor pushing against your inertia, creates a sensation indistinguishable from gravity. The math is elegant. Acceleration, A, equals the square of angular velocity, omega, times the radius, r. For a cylinder with a radius of just over 4 miles, we need only spin it at roughly 0.5 rotations per minute to replicate the 1G of Earth. A gentle, imperceptible waltz that grants us the weight of home. What would it feel like to live here, inside the curve? Your senses would first rebel against the view. You would stand in a park, feel the grass beneath your feet, and look up to see, not a sky, but another town, a river, or a forest hanging directly above your head, miles away. The sky is simply the other side of the world. But the illusion of Earth breaks down if you look closely at the physics. We are living in a rotating reference frame, and here, the Coriolis effect becomes a tangible part of daily life. If you pour tea, the stream curves. If you play catch, the ball defies your intuition. Throw a ball in the direction of the rotation, spinward, and you add the ball's speed to the environment's rotational speed. The gravity on the ball increases, it drops like a stone. Throw it against the rotation, anti-spinward, and you cancel out some of that velocity. The ball feels lighter. It floats, carrying further than it ever could on Earth. It is a world where the direction of your movement determines your weight. Beyond the whimsy of curving baseballs, the engineering must be fortress-like. Outside this thin bubble of air lies a cosmic shooting gallery. To replicate Earth's protective atmosphere, the hull must be shielded by feet of compressed lunar soil or asteroid slag, blocking the lethal hail of cosmic rays and solar flares. The O'Neill cylinder is more than a marvel of engineering. It is an act of defiance. It is the declaration that humanity is no longer bound to the random lottery of planetary biology. Planets are hard to terraform. They are gravity wells, trapping us in their depths. But these cathedrals of the void can be built from the debris of the solar system. We can dismantle asteroids and dead moons to build 1,000 Earths. We are a species of explorers, not because we hate our home, but because we have outgrown it. By spinning our own worlds, we carry the sacred fire of Earth's gravity with us, ensuring that wherever we go in the cold, dark ocean of the universe, we will always have a place to stand. And that is how we touch the stars.